All right, guys, welcome back to another video here talking about the fuel settings section in the Gen 4. We've already covered the system section in a previous video. We're going to go into the fuel settings section now. We're going to, like I said, keep working our way down in all these videos. If you actually have a section you want me to cover first, though, I can jump around, but I'm just going to try to go here from left to right to cover all these different sections that we have. We're also going to have a section completely devoted here, a video devoted to the graphing and logging section to make things easier, how to set up your logger, go through your logs, overlay logs, all that good stuff. So fuel settings section is going to be what we're going to talk about today. And one of the things that I wanted to point out here is that in all these different sections, including the fuel settings, we have a search bar up in the upper hand corner. So if I typed in fuel, I'm going to get a pull down menu, and everywhere I've got fuel listed inside the Gen 4 software, it'll go right to it. And really handy if you're not sure exactly where something is. If you're looking for something, for example, maybe you're looking for a decel fuel cutoff or a power valve curve, okay, it'll take you right there to that table. This doesn't have to be fuel. This can be spark. So now I've got everything listed here under spark here. Obviously there's a ton of stuff having to do with spark advanced, or maybe I just want to look up boost. And I got all this different stuff related to boost. So that search bar can come in really handy for depending on what you're looking for. And if you're more comfortable finding stuff that way and getting around the software. Okay. So we're going to get back into the fuel settings section here. And the first thing that we're going to talk about here is every section in the fuel, AFR, and ignition section has a modifier selection. So when we go to this modifier selection, this is basically where we're going to turn everything off and on depending on what you want on inside the Gen 4 software and inside your Gen 4. So on the left hand side, we basically have a bunch of adders or fuel takeaways, if you would, depending on certain conditions that are happening, and we're going to go through those in a minute. On the right, we have generic fuel curves and a ninth injector option and a nitrous PWM fuel correction option, which we're going to talk about here in a few. So let's talk about the very first item up here, which is the fuel spark lambda map. And you have the ability to choose between one of four maps in the software. So for example, I'm on fuel setting, or I'm on fuel FSL number 1, which means that for the fuel map, if I come over here, I'm on fuel table 1. If I'm on AFR, I'm on target O2 table 1. If I'm on ignition, I'm spark table 1. Now, if I entered a 2, or I pressed up, now I've got a 2 in there in that box. You're going to see here my fuel table's changed. If I come over to the AFR section, my AFR target table has changed. Same thing with spark. So you can load up, if I just jump to 4, I can go right to my 4th fuel table. Okay. And this is any way you want to program these guys. We've already gone through how to set up and configure these tables. This can be configured any which way you want, depending on how you want to run your engine. So you just have to remember when you make this change here, okay, you are affecting the fuel, AFR, and the ignition. They're all going to change together. Okay. So if I go back to 1, now I've got 1 shown here. Okay. So that's the first section right there, which we've covered. Next up here is going to be the decel fuel cutoff, DFCO correction. And what that is here is, this is a mode to when the software is configured, no fuel is going to be delivered to the engine. Now this typically happens when you're coasting down off a freeway on ramp, when there's just no load on the engine and you're coming down where the motor doesn't need any fuel. Okay. So the first thing you're going to see here is that if I come over here to my transient fuel right here, the DFCO parameters, okay, is over here. Now you're going to see it's empty. Okay. Well, it's empty because I have it disabled. If I enable it, now it's all going to come up. And if you follow the little question marks, okay, you're going to basically configure this guy so that the DFCO is only going to turn on under these certain parameters. So I'm going to turn on at 30 kPa, I'm going to turn off at 50 kPa. So as we start rising towards 100 kPa, which is atmospheric pressure, we're going to turn this sucker off, okay? The other settings here are going to basically be time delays, a minimum off time. If we get below 1500 RPM, no matter what, we're actually going to bring the fuel on no matter what. And if we're above 55 miles an hour, there is no time delay at all. So all this is configurable. This simply will cut the fuel off completely. You'll hear the tone of your engine change. It will bring no fuel on your motor. Now, one thing to remember is if you do go into this mode and you are running the auto tune from the laptop, you're going to have to be careful, because if you go completely lean and the O2 is showing dead lean because your DFCO is kicked on, your fuel map is going to get a ton of fuel hit in those sections, because the computer is going to go, oh my god, I'm dead lean, I have no fuel, I'm trying to get to whatever is in my AFR target map. The auto tune is going to start adding a ton of fuel. So just make sure that if you do want to run auto tune, you do disable the DFCO, so that way it can't screw up your map and give you some heartache there, where all of a sudden you're going really rich in certain areas and you're not really sure why. Okay, so that's DFCO. Coolant correction, that's pretty standard. Basically what we're doing is we're going to add fuel based on the engine coolant temperature, and that is right here under the coolant correction section. So depending on what map sensor you have, and depending on how you have these coolant ranges set up, it's going to be an adder. Okay, so this table is configured. Yours may be set up differently. Your motor may need different needs of fuel depending on when it's colder. Some need more, some need less. You'll have to kind of play around with that. Our standard map that comes in there is usually pretty close for most cars. But this is the coolant correction table based on what temperature the motor is seeing. Okay. Next one we have here is a power valve correction table. Okay, there are different states that the engine is in, and basically it's triggered. This state is triggered when we are accelerating or we're decelerating. Okay, depending on if you have a race car or a street car, this may be enabled or it may not be enabled. And that is all these sections here. Wherever it says power valve here, fuel, RPM, decrease, increase, you may want to use this. It's going to be completely up to you if you do want to use that or not. In this tune-up, we're not using it. Again, really depends on your setup and your combo if you do want to have the power valve correction enabled. It's only used under acceleration or deceleration. Okay. Next one is going to be this ES power valve correction. Again, same thing. Only when the engine is stable at a state 4 will this actually be used. It's up to you. This is just simply another correction that you can add as far as the engine getting it to run smoother. Has nothing to do with overall power control or power management. This is just simply a correction based on the acceleration of the throttle when the engine is stable here in this state number 4. Okay, next one is going to be air temperature correction, and this is enabled, and when this is enabled, this is going to give you a fuel percentage based on the intake air temperature. So again, if I look over here, I don't see it listed as disabled. Okay, if I come over here and I enable that guy, and it's going to pop right up. Okay, so in this curve right here, 32-degree inlet air temperature, we're going to add about 11%. If we see 150-degree intake air temperature, we are going to pull about 12%. So again, default map is usually pretty close if you want to use this. Nothing wrong with it at all. You can run it or you can not run it. After start correction, what this does is when the engine first fires up, there is a mode that it goes into to provide a fuel, and it decays out based on how the engine is running. So if I look over here in this startup sections, this is the after start section, after start correction, delay, decay, and there's some parameters here. Okay, this is everything that has to do with either having this disabled or enabled. So if that is disabled, okay, and I come over here, you're going to see it gone. Okay, I'm in startup idle section. The after start parameters live over here. Okay, you'll see it's gone. If I come back over here to enabled, now it's all going to be there. Okay, so I've got a correction curve, and again, this is a percentage. It'll say right down here, the after start correction fuel is added synchronously as a percent of the base pulse width defined in the fuel table. So this is a correction factor that is added the base pulse width when the car is first started. Okay, this only applies when the car is first started. Again, that's why it's called after start. And this is where you can also trim out your delays as far as when it actually turns on, and your decay of how long it actually takes to turn off. As you can see here with the crank cycle count, It's a crankshaft interrupt. So as the crankshaft is spinning more and more, it's going to give you a longer decay. So these numbers are going up, okay, based on the engine getting hotter, okay? So the engines go lower to higher based on coolant temperature. So you can have that on, you can have it off. Most race cars will not need that though. This will not be necessary for race car applications. Barometric correction. So every Gen 4's got a built-in barometric pressure sensor. And what's nice about this here is that you'll again notice that there's nothing listed here in the fuel settings section. If I come over to barometric correction section, I've got it shown now when I enable it. So all this simply does here is when you are at about 100 kPa, which is right around here, we're pretty much not going to add any percentage of fuel. But as you start going up in altitude and that baro starts reading a heck of a lot less, we can automatically start pulling fuel out based on that. So if you have a car that is driving around and you go through areas that are 5, 6, 7, 8, 9,000 feet, your barometric pressure is going to drop really fast. So the Gen 4 can automatically compensate for that and pull fuel out. Vice versa, for some reason your air is just getting way better than 100 kPa than typical atmospheric pressure, it'll start adding fuel back in. Okay, so if I disable that, now you'll see it's gone. E85 correction. Okay, so if you have the E85 option, okay, which is what this has, you can enable this. This tune-up does have E85 with a flex fuel sensor, and it will allow all these tables over here in the upper hand corner by the E85 section to work. And what these are enrichment percentages based on the amount of E85 that is in the system. So when the E85 is turned on, we have base values that are plugged in, but the way the Gen 4 is configured on E85 is that we're trying not make you have to add a ton of fuel when E85 is triggered on. We try to do a lot of it in the background, so you're not going to have to do a lot of enrichment here. Every car is different depending on the size of injectors, how the car is tuned, what it likes. But these are all correction curves based on the amount of E85 that you have. So for example, in this tune-up of this car, it doesn't really take much correction until we start getting to E44.5, 50.8%. You know, as soon as we start going up in that true E85 range, then we actually start adding some fuel. But you'll notice that below 38% E85 and below, we're actually adding nothing. The tune-up is very close. And that's how it's designed. It's designed so you don't have to have a ton of adders in there. You may have to. You'll just take some time driving the car around, seeing what it likes depending on the combo. All right, but these only work if you have the E85 option enabled on your computer. Okay. Next one here is we're going to have an EGT add fuel correction. So what we're going to do is, this is turned off right now, and in the AFR section we have a O2 and EGT configuration section. So you'll see here that everything's dark. It does list out cylinders here. Now it does say RIM 1 O2 and EGT cylinder goes to number 1. This will work with the PCS setup. This will work with a race pack setup, and this also works with the RIM modules as well. So any EGT sensor that you have in the system, this is going to work the same way. Okay, it does not matter which EGT setup that you go with. Now if I enable that, you'll see here that all of our numbers go on, and you can now configure all these tables to work for exactly how you want it to be. So if I configured cylinder number 1 to where if I saw 1300 degrees, I'm going to add 10% of fuel. Okay, same thing. You can adjust your cylinders to be whatever they were going to be. If you wanted one to be lower and add a different amount of percentage of fuel, this is where you configure everything. Okay, and right here is where if it says, you know what, I'm too hot, I just want to shut the cylinder down, it will turn your cylinder off. So if you don't like 1400 degrees on your combo, you're going to turn off your injector or injectors to that hole, and you're going to save that hole. Turning off fuel to one hole will not hurt your engine at all. Going lean is what hurts your motor. Turning off the fuel running on that cylinder, just pumping air, will not hurt it. Okay. So this is what the safeties is for. It's in place to try to save your engine based on EGTs getting too hot. Okay. So I'm going to turn that back off. Now, if I go back to the same section over here, O2 and EGT configuration, The next section here is this wide open throttle cylinder lambda offset correction. And this enables or disables the lambda additive fuel table, which is located in the AFR section. So if I enable this right there, you'll now see that I've got a whole new section pulling up there. Okay. Now, this is a target closed loop lambda offset. Okay. And you'll see here that it corresponds to cylinder number 1. Now, if you're running the rim modules and you have 802 sensors, you can have a closed loop lambda wide open throttle offset. So if for some reason you want to have a cylinder run a little leaner or a little richer, when it's in closed loop, it will automatically correct and get that cylinder back to where it is based on the offset that you have set in here. So if, for example, you're on a blower car and you're under 25-30 pounds of boost and your AFR target's 12.3, you may want to offset some a little leaner or a little richer, not have everything be 12.5. You could have one be 12.3, you can have one be 12.8. Just depends on how you're reading the engine and what you want it to be. So with this table turned on, this will enable that feature. Okay. Now, one other thing to remember is that when you're making these choices here and you're turning on these tables, you're going to have to cycle the ignition, because what happens is when the ignition is turned off and it boots back up, these tables are going to go true. Okay. So don't forget to cycle the ignition after you turn these guys on, make your changes, hit your burn. Okay. Because only actually when you cycle the ignition for these tables are when they're actually going to take effect. Okay. When the computer boots up and takes it. So I'm going to turn that back off. Next one here is a fuel pressure safety fuel correction. And what this does is if you have the ability and you have DAE and you're reading fuel pressure, it's going to look at your fuel pressure and we're going to do something based on the fuel pressure going down too low. Okay. Now where this lives is over here in this generic fuel pressure safety section here. Okay. So we have the ability to do this fuel pressure safety fuel correction 2 different ways. Okay, the first is a standard table where you enable it or disable it here in the generic section. And what this does is, for example, this is a street car. You have a 50-pound target when the key on, engine on, fuel pressure should be about 50 pounds. Okay, and we have an RPM trigger of 1,000 RPM and 10%. So above 10% at 1,000 RPM, we're going to be looking at this safety. The Gen 4 is going to log when it turns on what the key on, engine on, fuel pressure is. We're going to have an on PSI and an off PSI. We're going to wait a certain amount of time. It's going to be 1 second. And we're going to limit the RPM down to a 20 to knock the engine RPM down. Okay, so it's going to misfire based on seeing the fuel pressure going too low. Okay, so this is the first safety, which you can configure in the software for the fuel pressure itself. This will work just fine, okay, with a mechanical pump, and you read 0 psi. Okay, this will work perfectly fine. You can still configure everything to work with a mechanical pump with 0 psi when the ignition turns on. Okay, that's the first one. Now you'll come over here and you'll notice I've only got fuel pressure safety there. Now I'm going to come back over here to this fuel pressure safety fuel correction. I'm going to enable that, and boom, now we've got our table opened up. And what this does is this looks at the fuel pressure itself, and you can have the fuel pressure compensation curve be set up to do whatever you want. So if for some reason, if the fuel pressure starts going down past your target as well, okay, all the way down to 25% in this case, we're going to add 10% of fuel. Okay, so this will put 10% automatically back in without having it going closed loop to say, oh, I'm running really lean. This will automatically start increasing the pulse width of your fuel map to get you back there. Closed loop, hopefully if you're running it, will also catch you and grab you as well too. But this fuel pressure delta is where it's going to say, I'm running out of fuel pressure. I got to add fuel right away. It's not even going to depend on closed loop to try to get you back there and hopefully save the engine. Okay, this is going to hopefully catch it in time towards automatically adding in the fuel based on the fuel pressure dropping. Okay, that's where this lives. So you'll see it's obviously on right there, and I'm gonna turn it back off and you'll see it's gone. Okay, this ninth injector fuel correction, what this is here is the ability to run a single injector or 4 injectors using a big drive or 8 injectors using 2 big drives. And this is not to be confused with a 16 injector option, because this is basically a table that you can build to when you can have these injector or injectors come on whenever you want. All right. So if I enable this guy, you're going to see in the fuel settings, it turns on and populates right there. If I turn it off, you'll see it's not there. Okay. So I'm going to put this back on, and I'm going to come in here. And in this ninth injector pulse width table, this is a straight up pulse width table in milliseconds. So if I wanted to add a certain amount of fuel, let's just say I wanted to add 2 milliseconds from 3100 to 6000 RPM, okay, at 55 kPa or above. This is going to be a raw millisecond voltage, and it will start pulsing. And what a lot of guys do is just simply tee off from their existing fuel system and feed their fuel injectors. Now, this is a match aspirated setup here, but if you have a boosted combo to where above 10 pounds of boost, you want to start spraying in some extra fuel. If you have a mountain motor combo, a lot of guys use this for the 16 injectors. So when it goes above a certain RPM and kPa, we start bringing in the extra fuel that way. Again, it doesn't need to be our 16 injector option where we actually kick on a second set of injectors based on duty cycle. This table can be configured any way you want to drive another set of injector or injectors. Okay. Sky's limit on this one. Again, 1 injector or 2 big drives to add 8 more additional injectors, completely up to you. It will need you will definitely decycle the ignition for this one for sure. Again, when it boots down and it comes back up, it enables this option for you to take advantage of that. So I'm going to turn that back off right there. Now, on this next section, if you're using our Nitrous, you can configure the Nitrous pulse width modulation fuel correction tables here. Okay, this will only work if Nitrous is enabled on the ECU. So over here in this Nitrous section, okay, I don't have it actually enabled. So even though I've got the pulse modulation fuel correction enabled, you'll see it's all grayed out here because I don't have it enabled. So if I enable it, now you're going to see right here, I've got all these different Nitrous programmable settings I can mess with. But if I disabled that here, you'll see that I've gone gray now. So when I enable it, now you're going to see here that it's back. Okay, so you can do in either a pounds per hour or multiplicative percentage. If I go down to the fuel correction right now, it is set up for a fuel percentage. So this is a drag race application. So 1 second out, when it starts, I'm going to add 40% more fuel. You can do it pounds per hour, but this is the fuel curve that you're going to set up based on this option being used. Okay, and you can also do pounds per hour. It's completely up to you if you want to do it that way or not. All right, turn that back off. Now, these generic curves here, these are where we're going to get into any which way you want to enable an additional fuel to be brought in the engine based on a number of parameters. Okay, all these will require a restart when you're done too. So if I enable this generic fuel curve, actually I'm going to disable it first. Up here is where these guys live. So I'm working on the generic 1D fuel curve 1. If I come over here and I look, it's all grayed out. There's nothing there because I haven't enabled it. Let me come over here and enable it. And there you go. Now it's up. Okay, so if it's grayed out, it's not chosen. If it's available to be used somewhere in the software, it's turned on. All right. So I can either do an additive trim or I can do multiplicative trim. I'm going to choose a data source though to actually work with. So I can do RPM, TPS, and SR2 timer, which is basically going on the track, boost, mile an hour, coolant. There's a number of options to be able to choose from. I'll just stick with this example with RPM. So if I come back over here and I go in this fuel in the fuel curve here, I'm going to say, okay, in this example, I'm going to go from 4 to 9,000 RPM, but I want to do a fuel percentage. So let's just say I want to add 15% at 4,000, and let's see at 9,000, I want to add 25%. I'll just highlight that row and interpolate it. And this is now going to provide a fuel correction based on this RPM. Okay, nothing will start until 4,000 RPM. Then I'm going to start pumping in fuel. Okay, we talked about how to change all these other curves and make them look different here. So sometimes you can reset these guys and we can make it look better. But for example, if I made the minimum instead of 0, if I made it 4,000, we can get this graph to look better here. Anyways, but this table though, even though we've configured this and we've set it up appropriately, this is not done. We're not done with this yet. Because what needs to happen is, even though you've got the generic 1D fuel curve enabled here, and you've got it here and you've turned it on here, and you got things all set up, you got to go in the generic port editor and actually fire it up. So what I mean by that is, in here is where you actually turn on that fuel curve. If you do not come in here, none of these generics are going to work right. All right, so in this example, I only actually have that generic 1D fuel curve going active after 3,500 RPM, which makes sense because I've set it up to where it's actually going to be from 4,000 to 9,000. So I only want this curve to be enabled in this case when we're above 3,500, because that is how my generic port editor is set up. Okay, these will not work unless they are turned on in the generic port editor. And the reason being is because they are generic tables. We need to give the generic table a reason to turn on. What are the thresholds? What are the output channels that we're going to tie these to turn on? You know, what if I wanted to go to a TPS percentage as well, right? So that way I could just be at a certain RPM, okay, and I wanted to be greater than 75%, okay? So now in this case, unless I'm above 3,500 and I'm greater than 75%, that's when this table is going to go true, okay? You got to configure the generic port editor with a generic curve. Something has to turn on. And you got 4 output channels to tie with, to work with, to bring that channel on. And that's how all the generic curves work. This is just an example of the generic fuel curves themselves, okay? So I'm going to turn that back off. We're not going to use it. Now remember, if that's off, this is not going to be used. And these changes will definitely require a restart of the ignition to make all this stuff work. So after you've done anything with the generic port editor, you're going to cycle the ignition and come back up. All right. So I'm going to close these back out. I'm actually going to go back inside here and turn this off. Inside this fuel curve, I don't want this to turn on. All right, so that's the 1D fuel curve 1. This is the 1D fuel curve 2. Exactly the same thing. You can have a second one. So I'm going to turn this back off. Now, if I go into my generic 2D fuel table, I can choose a different X or Y axis to work with. All right. Now, in this case, I have an RPM for the X axis and a TPS for the Y axis. If I come over here in my generic 2D section, okay, I now have a map that pops up. This is just a generic map here. Again, in the previous video, we showed how to set these up. This is between 250 and 1100 RPM, and this is between 0 and 72% TPS. This is configured for pounds per hour, as you can see up here. I could come over here and do it multiplicative, and I can come back here, and now I've got a percentage of what to do, right? So I could just say maybe this will be adding 10%, and instead of negative, we'll be adding 10%. And then I could just interpolate all those rolls over. Again, it doesn't matter how you want to set this up. This can be configured any which way, but this is how you configure each axis to be set up with whatever you want to choose. Maybe I don't want it to be TPS on one side. Maybe I want it to be boost. Okay, now the boost is going to be controlling it on that side. Maybe for the x-axis, I want it to be mile an hour. Okay. So it really just depends on how you want to set it up. Okay, all these generic curves though, you can't forget to come into the generic port editor and fire them off. They are only going to go active based on you doing something. So as you can see, you could do all your work inside the generic 2D curve, but unless you come in here and tell it when to turn on, it's not going to do anything. And we've already covered another video how the whole generic curve works, or I'm sorry, the generic port editor works. So go refer to that video to see how to configure this guy. All right. So that's going to be it for the fuel settings section. That's going through everything. So hopefully you got something out of this video. Please don't forget to like, throw a couple comments up there, share it to some of your friends. And the next video we are going to cover is going to be on the startup idle section. And I'm Ben with Bigstuff3, and have a good day. Thank you.